Hey folks, hi, welcome back. We are today at day 5 of Advent of Code. And if you're new here, I am Jatin Kumar Malik. I'm a principal software engineer at Atlassian, and I absolutely love solving these puzzles. Every year, last year, I did like a small medium block playlist. This year, I'm doing YouTube because I just feel it's much more interactive. And then I'm more interested in understanding and helping you to solve the problem and understand the logic behind it rather than just writing code. Because let's face it, right? Writing code is the easiest part of solving a problem. And yeah, shameless plug. Like, if you are directly jumping onto this video and if you haven't seen my last 4 videos of day 1 to day 4, I would recommend you to go ahead and start with day 1 and then gradually build up and come back to this video because Advent of Code has this really interesting pattern where it starts off really easy, like a ladder. But as you progress day over day, the problems get much more interesting and complex. And yeah, before we get started, also we have a new webcam. So I'm shooting this with my new 4K webcam. So the display stream should be much better since the last video. And this one has a nice autofocus as well. So if you can see, it can focus on my friend Trooper here. Trooper is, by the way, name of my gaming PC. And yeah, today we are inside a pentagon, as you can guess, because it has 5 sides and you can guess what day it is. Okay, I know. Enough of my nerd jokes. Now let's get started. So let's get like a good pen here going on and let's put day 5. And it's pretty late right now. It's 11:56 p.m. in Chicago because I was a little busy, but it's been around 57 minutes since the problem was out. So let's see. Day 5 problem is called print Q, and let's read it. So, satisfied with their search on the Ceres, the squadron of scholars suggest subsequently scanning the stationary stacks of sub-basement 17. The North Pole printing department is busier than ever with this close to Christmas, and while the historians continue their search of this historically significant facility, an elf operating a very familiar printer beckons you over. And we can see this is the reference to 2017 day 1. So the elf must recognize you because they waste no time in explaining that the new Slay launch safety manual updates won't print correctly. Interesting. Failure to update the safety manuals would be dire indeed, so you offer your services, just as a good problem solver. And safety protocols clearly indicate that new pages for the safety manuals must be printed in a very specific order. So there is a notion XY, so we will write it down XY. That means that if both pages X and Y are to be produced as a part of an update, the page X must be printed at some point before page Y. So it's basically like a dependency that if you are given a request to print Y, you need to ensure that, the X gets printed before Y. Perfect. So I think the good part of working so long in industry and doing probably countless of hacker rank lead codes and interviews is that I can already see where it is going. A hint, one word, topological. But let's read on and let's not get ahead of ourselves. So the elf has for you both the page ordering rules, which is this one. So this is an ordering rule for us. And then we have pages to produce in each update. So your puzzle input. But you cannot figure out whether each update has the pages in the right order. I told you it's topological sort. And we have an example given here. Let's take this example on our screen. So as it said, the first part is the page order. So I will probably keep it here nice and easy in the corner. And the second part is the updates that we have to print. And let's see if I can align this. So perfect, like this. And let's increase the size of it. So yeah, so again, it says the first section specifies the page ordering rules, which follows this pattern that we can see here. 1 per line. And obviously the first rule here, it means that 47 should be printed before 53. This means 97 should be printed before 13, 61, 47. This means 75 should be printed before 29 and so on. And the second section is basically each update. Yeah, so we can see that these are our ordering rules and these are our updates here. So if we write it down, our updates are given here. So what it is saying is that to get the printers going as soon as possible, start by identifying that which of these updates are already in right order. In the above example, the first update is in right order. So let's verify that. So we will basically do like a quick dry run. We'll take some other color. This is the first update. We are going to read it from left to right. And we can see that the first command we get is to print page 75. So let's find page 75. So we can see page 75 is here. We have page 75 here. And we have page 75 here. We have page 75 here. And we have page 75 here. And basically this gives us a list of all the numbers that 75 should be printed before. And we should also look at the second column to find page 75. So we can see page 75 here. And that's all. So assuming that we print this in order, moving on to the second one, we come to 47. And as soon as we come to 47, we can see that we have to look for 47 here. And it says that 47 should be printed after 97, but we have not printed 97 yet. So we are good. And let's look at the another 47. We see another 47 here, which says that 47 can only be printed after 75, which seems to be the case. And we cannot really find any other 47 here. And now coming to the third number, that is 61. So we will do the same thing again. So we will look at 61. So 61 we can find here. And it has a condition that 61 can only be printed after 97, but we haven't had any 97 yet. And we don't have any 97 in this string. So we are good. We are going to look for more 61s. So we can see 161 here. And here is a rule that 61 can only be printed after 47. And we can see that it was indeed printed after 47. And remember, it doesn't have to be exactly after that, because it just said, right, I think here, yeah, it must be printed at some point before page number Y. And that makes sense, because if you see here, like we have a bunch of numbers repeating, like for 97, that there is a condition that it must be printed before 13, 61, and 47. But moving on, we have another rule for 61 here, and it says that it should be printed after 75, which is also correct because we have already printed 75 and looks like we are good. So moving on to the next one. So the next one is, again, let's take another color. So next one is 53, and let's look at 53. So 53, we have a rule here. It says that it should be printed after 47, and we can see that it was indeed printed after 47. And there is no 47 after that. We will look for another instance of 53. It says that it should be printed after 75, which seems correct. And so on. We will look at 53 should be after 61, so which is basically just the previous print instruction. And 53 should be printed after 97, but we don't have any 97 in the first update. So we are good. And I think we are good with 57. And then we are back to our last number, which is 29 here. So we can find 29 here. And it says that it should be printed after 75, again, which is correct. Looking for another rule, we can find another rule of 97, but we have established that there is no 97 here. So we are good. 29 should be printed after 53, which indeed it is. And 29 should be printed after 61, which again it is. And we have another rule where 29 should be printed after 47, and it is. So as we can see, like doing this little dry run, that this is how we are making a check. And if this whole update passes, we basically say that this is a valid update for us. And if I scroll down, I think it is trying to explain the same order, and which means, yeah, so this is a valid update to print, right? Now look at the one which may not be correct. So we can see, like, maybe let's pick this one. I'm not going to dry run through all of them, but I think feel free to pause here, pick up a copy and pen, and try to do a dry run for all of them. So we will start with 61. And the only thing we need to check for the first element here is that it should not have a prerequisite to be printed before something. So if we look at 61, it says that it should be printed after 97. And that is not valid because we don't have any 97 here. And if you look for any other condition for 61, we have one for 47, but we don't have any 47. Then there is 75. We don't have any 75. So we are good. Moving on to the next element, so 13. So now looking at 13, 13 also has a similar condition where it says 97, but we don't have it. We'll move to 61. It seems like this condition is fulfilled because it is indeed printed after 61, as we can see here. And so 1329. So it says that 13 can only be printed after 20 line. But if we see here, 29 is being printed after 13, which means that this condition is not fulfilled, which means that this update is not valid. So basically, we can go through each of this updates to verify what updates are correct and what updates are not correct. And then let's see what we need to do. Let's read the question. So it's basically talks about like what are all the ones that are in the order and what are all the ones that are not in the order. So it seems like the first one is in the order, the second one is in the order, and the third one is in the order, and these ones are incorrect. So these three are the ones that are correct. So what do we need to do? So for some reason, these elves also need to know the middle page number of each update being printed. And because you are currently only printing the correctly ordered updates, you will need to find the middle page number of each correctly ordered update. In the above example, the correctly ordered updates are these three. So if I just copy them here, yeah. So we can see that we are only interested in getting the middle number here. So if you see the middle number here is 61, 53, and 29. And also interestingly, to get like one middle number, it seems like the order will have to be like an odd number of digits, because if it is an even number of digits, we will have two middle numbers. So let's see if that is an edge case, by the way, if they mention that. And it seems like we got these, and then we are doing like a sum of these, which gives us a total of 143. That is the answer of this test case. And it does mention, of course, you will need to be careful. The actual list of page ordering rules is bigger and more complicated than the above examples, of course. Hint, like if you haven't seen day 4, part 2, you should check that and you would know exactly what I mean. But so the question wants us to determine which updates are already in correct order and what do you get if you add up middle page number from these correctly ordered updates. And if we see our puzzle input, it's basically pretty huge. Yeah, so coming back, I think this is where I want you to pause and think about the problem that we are discussing here. And I think the two questions that you need to ask yourself is that how can we arrange these rules in some kind of a data structure so that it's very easy for us to check this? Because remember, whenever we are looking at one element, we are trying to find all the iterations here, and then we are looking through them. And I think the second question you need to ask yourself is how would you do the validation for each? Because it's not just that we are looking backward for all the rules. It seems like we also have to look at our update and the future elements to validate that we are not in breach of any of the ordering rule that is given to us. And the hint too for you, if you haven't been able to think about it, it's like, I think this can be a graph question. And I gave a couple of hints with topological sort in like few minutes back. But graph where you can put these nodes in a dependency order of fashion. And then whenever you traverse through your update, all you need to do is you need to traverse through the graph to see that all the conditions are being met. And you should be good, right? So now is the time to grab some coffee, write this problem down, and try to write a code for that. And remember, I think the good approach is to start with the given test case first. And once your test case is passing, then you can move on to getting this puzzle input and trying to solve for that. And while you do that, I'm also going to go ahead and write some code so that we can put the answer here and move to the part 2. So with the magic of video editing, I will actually just see you in a few seconds, but it could probably take me a few minutes to solve this. So I will see you soon. Hey folks, and we are back. And as you can see, we have achieved 1 gold star because we were able to find the right answer. And interestingly, what I did is like before I started writing any code or before even doing anything, I just looked at the input. So I noticed that in the input.txt given, as you can check for this problem, there were some 1100 rules, but there were only 200 updates that I had to check. And this is an interesting lesson, I think, in coding. And probably a lot of times when you are working on a production level code, a lot of times the code you write is optimized based on the data it is about to process. So I remember I did nudge you towards looking into a graph and creating a graph and doing that. And I did exactly that in a way, but I did something clever. So what I did for my approach, and I will push the code to GitHub, you can find the link in the description. But what I did is I took the rules and I basically just kept them as a tuple. as they were given. So x comma y, a comma b, x comma a, b comma y, like, and so on. And then since there were only 200 updates for me to go over, I went through each update. So let's say there is an update called where we have a comma b comma c comma x comma y, and this is the update. I realized that all I need to do is that whenever I pick one element in the row, I just need to take that. I need to find all the rules that pertain to that one. And then all I need to ensure is that the index, in this case, which is 0, that index of that element should be should be greater than the index of all the numbers that I can find in rule. So basically index of rule of I. So to explain it in simple words, that if you go back to the example that was given above, and if I pick, let's say, this example, it's not very clear, I know. So 75, 29, and 13. So when I pick 75 and I look for all the elements that have 75 on the right side. So yeah, 75 here. I think we only have one entry. All I actually need to do is I need to check that. I think there is an exit condition. I just need to check that if 97 exists in this array. If it does not, we will just exit and we will move to the next one. So let's move to 29. And I find 29 here. And as soon as I find 29, I first check that if 75 exists in the array or the list of this update. It does. And if it does, since 75, 29 can only be printed after 75, all I need to check is that the index of 29 in my list should be greater than the index of 75. And that's what I did. And just to make this process faster, because the updates were sometimes pretty long, what I did is I encoded everything into a dictionary, where if we take this example, I basically just created a dictionary where I said A has 0 position, B is on 1, C is on 2, D, X is on 3, and Y is on 4. And what it allowed me to do is, like, whenever I looked at A, I looked at all the rules, I could just very quickly compare the positions, and I could exit early, right? If both elements are not present, just exit. If elements are present and they're like A is not coming after X, exit. And then becomes like you mark that as successful, you store it in a list, and at the end, you basically have like a list of all successful updates. You find their middle elements, you get their sum, and boom, here you are. You have one gold star. So I hope this explanation was helpful. And if it is not, I will, as I said, I will post the code below. I'm sure there is a much better and much more optimal way of doing it with graph, or maybe even creating like a topological sort and tree. But I just did not feel the need to do it in part 1. And I'm again not trying to foreshadow for part 2, but probably we will need to optimize this, but it works for now. So let's move to the part 2. I'll click here and here it is. I'm going to blur the answer. And part 2. I am blurring the answer, but probably it should not matter because the creator of Advent of Code is fairly smart. So what they do is, since you're logged in here, so I'm logged in here, if you can see with my GitHub ID, they basically give you a different set of input data for your ID. I'm sure the sets are limited, so there are 4 to 5 sets, but it's pretty clever actually. So let's read the part 2. It says that while the elves get to work printing the correctly ordered updates, you have a little time to fix the rest of them. For each of the incorrectly ordered updates, we can use the page ordering rules to put the page numbers in the right order. Interesting. And for the above example, here are 3 incorrectly ordered update and their correct ordering. So basically what it is doing is, like, if I go up and take the example, maybe the one that we took, 61, 13, and 29, it is, so like if I take that, it is trying to fix it where it's saying that 65, 13, 29 becomes 61, 29, 13. So we can do a very quick dry run here, right? So these are the ones that failed last time when we were doing it based on our rules. So let's take the first one and see where it was failing. So we will first quickly start validating it, and we will see that 75 here comes first, and we will look at occurrence of 75 here. We see 75 here, and we see that it failed here itself because it said that 97 should be printed before 75. So what I think we can do is we can basically just swap them. It's just a hunch. So let's see. And I'm just going to put it down. So then this becomes, so probably I should use this. And we can see that this will become 97, 75, and this. And this would mean that now this condition that we were failing on, this will start passing. But whenever we swap something, we will also have to now check for 97. So if you look for 97 in this row, we can see that there is no entry of 97. So we are good. And 75, we are good. So let's look at the next one. So next one is, let me change the color so that it's clear. So next one is 47. So for 47, let's find the entries. So we find an entry here, which says that it can only be printed after 97, which is correct. And let's look at another 47. So we find another 47 here. It says that it can be printed after 75, which is also correct. And then there is no entry. So this is fixed. Let's move to 61. So 61, we have an entry. It says it can be printed only after 97, which is correct. Let's look at the another entry of 61. So here, after 47 and 75. So after 47 and 75. And this is also correct. And looks like 61 is also good. And coming to the last one is 53. So 53 can be printed after 47, which is good. 53 can be printed after 75, which is also good. 53 can be printed after 61, good. After 97, good. And then there are no more entries. So as you can see, the correct string here is 97, 75, 47, 61, 53. And similarly, I think we can do the same thing here where 61, 13, 29 becomes 61, 29, 13. And then similarly, the last string becomes that. So interesting, like how will we do that? I think this swap approach is like an interesting hint that I have given. But pause here and think, what can we do better? And the good part is that we have this rules here. And these rules, if you arrange them in a manner or even sort them in a manner, there is a way where you can basically create like the ideal array or ideal order that should always pass. And I'm saying that because these are the ordering rules. So it definitely means that by definition, there should not be any conflict, which means that if I say 47, 53 here, it can never be the case that later I will see 53, 47 because this is against the rules. It cannot really happen. So if I can find some way to sort this in a way that it can always give me an ideal letter, I can basically create an order that whenever I encounter a wrong, let's take this example. So whenever I encounter a wrong element, so in this case also, if I remember correctly, so 61 itself failed because 61 had a condition. No, 61 was fine. 13 had a condition. This was the cause of failure here. That 13 can only be after 29. And this basically result in our failure. So since we already know that some element failed at some element, what we can do is if we can find a way to sort this, we can actually just use that to correct this order. Yeah, actually this thing that I'm explaining, this is exactly what I was whispering before. This is exactly what is a topological sort. So I would suggest you to look into that. Try to find the algorithm rather than directly going into the solution, and then try to see that how we can apply that algorithm here to fix all the incorrect ordered updates and fix them. And what the puzzle wants us to do is that after taking only the incorrected ordered updates, so all the rejects from the part 1, and ordering them correctly, we have to take again their middle numbers and then add as a sum, and then that should be the answer of our puzzle 2. So while you think about that, what I'm going to do is I'm going to pause the video here and I'm going to go back, write some code and try to see that if we can get the second star. And yep, as you can see, this is what we ended up doing instead. And we have the second gold star. And with this, we have started to unlock this beautiful sky art. And yeah, so talking a little bit more about part 2, I followed the basic Kahan's algorithm for topological sort, and I actually thought that I would explain that here. But honestly, I cannot do it justice to how well this MIT OpenCourseWare video that I'm going to link here explains that. Professor Eric Demain, that's one of the best explanations of graph theory and topological sorts I have ever seen. And I still remember I was in my third year of college when this video dropped and I saw it for the first time, and it immediately cleared everything I had to know about graph theory. So definitely check this video out and this will help you a lot. And yeah, we are at the end of the day 5. Hope you guys had fun. I certainly had a lot of fun. And do give me feedback about the 4K quality. Does that make a difference? Do you have any other feedback? So I would love to read some comments below. And check out my other videos from the same playlist. And guess I will see you in 24 hours when the day 6 drops. And who knows what my face cutout shape would be next, right? Have a great day, guys. See you. Bye-bye.